IB, Standard Level, Chapter 18, Normal Distribution. Okay, the normal distribution is used to model a continuous random variable. The model is a bell-shaped curve centered around the mean, as you can see below. The notation is x is distributed normally, and we need the mean, which is mu, and the variance, which is sigma squared, or standard deviation, which is just sigma. Really important that when you're reading a question, you look whether they give you the variance or the standard deviation. Okay, you don't really need to understand this for IB, but it might just be useful for you to know that the bell-shaped curve is centered around the mean, and that the data, the width of the diagram is dependent on the standard deviation. The total area under the curve is equal to 1. This is a really good check because anything left of the line would be a half, and anything right of the line would be a half. And so it checks that your answer makes sense when you get it. The normal PDF on your calculator calculates P of x being equal to small x. The normal CDF function calculates P of x being less than or equal to little x. Because your data is continuous, there's actually no difference between P of x being less than or equal to x or P of x being less than x. This does not apply to binomial distribution, only to normal distribution, because that data is discrete. So let's do an example. The average mean height is 167 and the variance is 144. So I take a note to myself, that means the variance is 144. So following the notation, x is normally distributed with a mean of 167 and a variance of 144. So that means the standard deviation, sigma, is 12. So let's have a look at the probability of x being less than or equal to 159. So I'm going to use my calculator. It's the second vars as in the distribution function, and it will be number 2, normal CDF. So I'm looking for my normal CDF. So let's go to second vars. Number 2, normal CDF. I've obviously already started this one, so I wanted my lower limit, you just leave it. Then you have 159 as my upper limit, because that's what I'm trying to find out is less than or equal to. My mean was 167, and my standard deviation is 12. So this gives me 0.252, three significant figures, 0.252. And what I've just done is find the area to the left of 159. Note I said that this area past this line would be a half, so that's around about the right kind of answer. PDF, let's just discuss this, although it's much less common in the exams, would be x being equal to. So on your calculator, that would be the first option, PDF, and that would be equal to 0.025, and that's literally the value of probability at that point. Okay, so when you have things that are going to be like a probability of more than or equal to a value, so in this case 176, there are two ways to approach this question. The traditional way of doing it, and then there's like a different extra way with the IB calculator. So I told you that the tables and the information was to do with x being less than or equal to. So because I want more than or equal to, I'll need to do 1, which is the area of the whole curve, take away the area of x being less than 176. It's continuous, so these two statements are, there's no difference between them. So the line here is 173, so I do 1 take away that area, which gives me the orange area. So I'll just show you that. So we've got it. So on CDF, and this time I wanted 176. And you can see I have 0.773, which I have here. So the answer is 0.227. Now, the normal distribution a long time ago was before calculators. And this applies at A level, but not so much at IB. That rather than having a different model for everything, things were adjusted in terms of a standard deviation and a specific mean, where the mean was 0. There's a calculation for this, which I'll cover in my next video. And there was loads and loads of tables in a book that you could look up values, and you could only look up less than or equal to. So this is traditionally where this comes from. But the GDC allows you to do it the other way around. So let me show you. So what you can do is if you go to your distribution, you can set the lower limit as being 176. And then you need to set the upper limit, which you can do by pressing the EE, which is with the kind of hyphen, 99. And then press the information. So instead of me going from the line down to sort of minus infinity, I go from the line up to infinity. And this gives me the answer directly. The only disadvantage is you might forget how to put your calculator back. So what you'll need to have is this being minus 1 to the 99, and then this being the original value. So if you feel that you can remember to set your calculator back the right way around, then you might want to keep it like that. But it depends on how well you remember how to use your calculator. Okay, so let's say we want to have a value that's in between. So let's have x being probability of being between 159 and 176. This is this area here. I work out the area of the whole thing, take away the area here, and that leaves me with the middle. I already have these values because we've already done those ones. So it's 0.773 and minus 0.252, which gives me 0.521.